All right, a bunch of the stuff that we're going to look at right now, we've kind of already looked at with the PES stuff. It's kind of a chicken and egg situation. You can't learn one without the other, and you can't learn the other without the one. So some of this might be a whole lot of repeat, unless, of course, you're looking at this first. And if you're looking at this first, then it's going to be brand new. So basically what we're doing is we're going to look at the electron configuration, or sometimes it is called electron notation. And I learned it back in the Stone Ages as spectroscopic notation. Not exactly sure what's up with that, but part of that is ingrained into my brain. So if you see spectroscopic notation, it's all the same thing. So remember, we looked at these ideas of quantum numbers, which tells us that there are shells and there are subshells, and those subshells have different numbers of electrons in them. And remember that they occupy different places on the periodic table. And there's all manner of different kinds of periodic table. We're used to seeing this one right here. This is the one that we are used to seeing. This is the most popular one. But there are other ones that are just as valid. For instance, here's one where, excuse me, they have put all of the S's that are over here on the right. And again, you just follow this along from left to right, and doing so like this. I'm not exactly sure why this one wasn't more popular than the one that we have. Here's a fun one. This one here shows, again, the different periods and the different groups. You start here at hydrogen and you work your way around in a spiral kind of a fashion. What's cool about this is that obviously everything that is in a particular section here are ones that share similar properties. So helium, neon, argon, krypton, xenon, and radon, those are all the noble gases that we would expect to see in, like, well, heck, where are those? On a normal periodic table, those are way over here, right? Too many periodic tables to look at. So there are all manner of different kinds of periodic tables that you could look at. Here's another one that shows the different things. But again, the whole idea being that anything in a particular column are elements that share similar properties. That one just makes my brain hurt, but I guess there's something to that one. There's one that is a circular kind of periodic table. There's a pyramid scheme one, and so forth and so on. There's a three-dimensional one that you could make. So there's all sorts of different types of periodic tables, but the reality is you're probably just going to see 99% of the time this traditional one that looks like this. But just know that there are other ways of imagining these. Now again, we expected the orbital order to go in the typical order, the 1s2, 2s2, 2p6, and so forth and so on, all the way up. But remember that because of overlap and subshell split, those subshells begin to take a different order of things. So there's a whole lot of overlapping, because again, as those shells get further and further out from each other, they get closer and closer together. And so consequently, that nice, neat, expected order that we would see here like this doesn't really happen. So consequently, we talked before about the order of filling. You can do the diagonal thing if you want. Here's another periodic table that orders everything by the correct order of the subshells. So this is the actual order of the subshells as they are filled. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, all the way on down. This one, you can tell, is probably not as popular as some of the other ones, because it doesn't look as nice and neat. But there is an order to this if you know the code to everything. So remember that every one of these elements has a particular order in which you fill those electrons, and for the most part they just go in order. There are a couple of goofy ones. You'll notice chromium here has one that's out of order. So chromium here has one that's S1 and D5 when it really should be 2 and 4. Copper is S1 and D10 when it really should be 2 and 9 there. What's up with that? Well, maybe we'll talk about that in a